Here we're asked to graph the functions y equals sine 2x, y equals sine pi x, and y equals sine of x over 2 on the same axis. These problems are all very similar to graph. The only difference comes up in the number that is multiplying x in each function. So we can see in the first one, x is being multiplied by 2, the second, x is being multiplied by pi, and in the second, it's being multiplied by a half, or you could look at that as dividing by 2. This number here will change the period of the graph, or stretch it side to side, pull it sideways, or squish it in. And you've learned at this point now that the period, or how often the graph repeats, is equal to 2 pi over b. And b is that number here, 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 or here, and that tells us just how large the period on the sine graph is. So what I'm going to do first is make a quick graph of just regular y equals sine x, which we aren't asked to do, but will help us in the long run, I believe. So, graph from 0 to 2 pi, put in pi, pi over 2, 3 pi over 2, we'll go up to 1, down to negative 1, and the graph will go middle, up, middle, down, middle, and we can connect the dots in a nice sine curve. That's y equals sine x, which has a period of 2 pi. So y equals sine 2x will have a period, using our formula, of 2 pi over 2, or just pi, which means it's going to be half as big as the graph that I had just made. So it will start in the same place, but it's going to need to finish by the time we get to pi, which means halfway in between, that's our middle point, will have to be at pi over 2. Halfway in between those, pi over 4 and 3 pi over 4 will be the high and low points from the sine graph. We can connect dots, and you can see that what we've done is taken the red graph and squished it by a factor of 2, so it's actually half as big as it was. The same thing will work for the next graph, for y equals sine of pi x. Put this in green. We take 2 pi divided by pi, it will have a period of 2. Well, this is actually going to be a little bit tricky to graph on the graph we currently have, because if I have a period of 2, that scale doesn't match up very well with the radians and pi, and it's a rational number instead of an irrational number. We can try to make our best of it. I know that pi is about 3. I'm not sure exactly where 3 pi over 4 is, so we can look at our calculator and see that 3, pi over 4 is just about 2.3. So I want my entire graph to finish just before 3 pi over 4. And I know that it's going to start in the same place. It's going to need to hit the axis of the wave, or the x-axis in this case, just around 1, which if you want to, you can again check and see that pi over 4 is just under 1, so I want to finish just after there. But pi over 2 is in fact larger than 1, so I need to get to that point before that. And we'll go up, down. Here, this point should be 2. This is 1, which makes this 0.5. And this middle point here should be about 1.5. And that's our graph. Our final graph, sine of x over 2, the period here is 2 pi over a half, which actually works out to be 4 pi. And so our period is actually going to need to be twice as large, all the way out to 4 pi. That's where we're going to get back down to the bottom of the graph. Halfway between 0 and 4 pi is 2 pi. We'll hit the middle between 0 and 2 pi. Halfway between those is pi. That's where we'll reach our top point. And let me change colors before I forget. Our graph should go up, back down, should meet our lowest point at 3 pi, and go back up to 4 pi, and of course all of these graphs could continue on in either direction.